In the previous video, we have discussed about the timer 1, the programming on the steps what we need for a timer 1 and the different modes what we have used, and we have even discussed about how to stop and start the timer by using the two bits like control bit and overflow flag bit. So today let's continue with the same example what we have taken in the previous session, how to calculate the time delay in the delay subroutine. Hope you remember this is the program we had written for creating a square wave with the 50% duty cycle with the initial value what we have taken was F2. So already we have said, so this FF will be loaded into the higher part and F2 will be loaded into the lower part, and we will be using port 1. So and since we are using a square wave, so we need we are generating a square wave, so we have to complement it, so we'll be nothing but toggle we need to do. That is why we went with CPL. Then we had called on delay. So in the delay we had written the first instruction, that is set BTR not, nothing but we are supposed to start the timer, right? So with that we need a timer run control bit, that is what TR0 we have said. So 0 says that we are in timer 0 mode, right? So timer 0 we have taken, and set B is to start up the timer. So next we have to keep on continually checking the status of your overflow flag, which makes us to check out whether we have reached the maximum value. Once we have reached the maximum value, we will be rolling back from rolling from maximum value to 0. At that condition the TF will be changed to 1, right? So now in this program what we have written the delay, now we will discuss how to calculate the amount of delay for this subroutine. So here, to calculate the amount of delay, first let's find out the timer frequency. So we have already discussed the timer frequency will be always 1/12 of crystal frequency, right? So now when we are taking 8051, the crystal frequency is nothing but 1/12 into 11.0592 megahertz, right? So 1/12 into 11.0592 megahertz, for which we will get it as 921.6 kilohertz. 921.6 kilohertz. So this is the timer frequency what we have. Now find out the period. So period can be calculated as 1 by F. So 1 by F is nothing but 1 by 921.6 kilohertz. Therefore T is equal to 1.085 microsecond. So this is the delay what we are, period what we have calculated. Now let's find out the delay. So to find out the delay, the first step is we will take out the maximum value minus the initial value, that is total number of counts we will find out. The maximum value is FF and the initial value what we have loaded is FF2, so which results in D, nothing but 13. So this is the total count. We will take one more extra count, that is 13 plus 1 we will take. So this one, so this is to roll to 0, because when we have reached the maximum value it will be rolled back to 0, which will take one more clock. Therefore the total count will be 14. So the total count will be 14. Now so total count into period, that is 1.085 microsecond is equal to 15.19 microsecond, which is for half pulse, which is for half. If you want it for full, then it will be 2 into 15.19 microsecond, which is equal to 30.38. So this is how we can calculate the total delay what we had written in this program, or what we are going to calculate with respect to this program. So first we will find out the timer frequency, then period, then the total count what we need, and if you are that total count will be calculated for the half pulse, then you can go with the entire pulse, which will be multiplied by 2. So this is what I had said for calculating the delay subroutine. Just now I showed you the calculation. So it will be 30.38 microsecond for full pulse. For the same example, let's calculate the frequency of the square wave. When you want the frequency to be calculated, so here we need the machine cycles for each instruction what we are using. So now you can see here for the first two instructions where we are loading the initial values into the higher TH and TL, that is higher byte and lower byte, we will be using 2 machine cycles each. For toggling we will take 1 machine cycle. Similarly for the different instruction we have taken the machine cycle given, which will be giving us the total of 28. So we'll have totally 28 machine cycles. So now we need for both positive and higher and low value. Then period what we have. So this will get us 60.76 microseconds. Therefore total period is equal to 60.76 microseconds. So with this we can calculate the frequency, which is equal to 1 by t. 1 by t is nothing but 1 by 60.76 microsecond, which will get us 16458 hertz. 16458 hertz. So now if you want to find out the frequency, you need the machine cycles, which is need to be calculated, and if you want to go with the delay, then we have how to calculate the delay. Then we need the total count what we have used with respect to the program. This is the representation we have taken here, how to calculate the total count what we have. So in the previous example I just said, so we will take out the maximum value minus initial value, then we'll add plus 1, so that is what roll over to 0, because from maximum value to 0, that gets it hexa, which will be multiplied with your period into t, multiplied with by period, so which gets us the total count, right? So which is, this can be done, that is maximum value minus initial value plus 1 into t. This can be calculated with respect to hexa. If you want to calculate the same in decimal, so we will take the initial value what we have, just convert that initial value to decimal, then subtract it with the highest value. Sorry. So initial value, take the initial value, convert it to decimal value, subtract it with highest value, that is 65,536, and multiply it by t. That gets you the count, which is nothing but we are calculating the delay. So let's do the same with by taking an example. This is the example we have taken. So here you can see, so we are taking port 2 here. We have taken a timer 0 with mode 1. Next you can see the initial values which has loaded like B8 and 3. So TH is holding B8 and TL is holding 3E. This is the initial value we have loaded, and we have taken, since port 2 we will be going with the set B P2.3, nothing but your TR0 we have used, that is run control bit, that is to start up the timer. Then we will keep on continuously checking out the overflow flag, which makes us to take the decision like whether to continue the counting or else we have to stop. That is, stop means once we have reached the maximum value, it will be rolled back to 0, where automatically the TF flag will become 1, right? So TF flag becomes 1 means we have to stop the timer. So then you can clear it both your run control bit and your overflow flag bit. Therefore again you can load the initial values in TH and TL. You can keep on doing the procedure. So now, so calculating the delay, just now I have shown how you can calculate the in hexa mode and decimal mode. So in hexa means, well, first we will take out the count. So count into the period value what we have taken or what we have calculated. Now, so with this example, we will both in hexa and in decimal, we will try to calculate this total delay. So now the if you go with hexa, then it will be like maximum value minus initial value what we have is B8 3E plus 1 what we have to take, right? Maximum value minus initial value plus 1 into t. So with this you can get the value as 47C2. You will get it as 47C2, which is in hexa. Convert this value to decimal, which you get it as 18370. 18370 into the period. So period is, so 18370 into 1.085 micro. So where we will get it as 19.931 millisecond. So this is with respect to calculating the delay with respect to hexa. So you have to take the initial value, then maximum value. So maximum value minus initial value plus 1 into t. The value what you get it in hexa, convert it to decimal, multiply it with your period. So if you want to calculate the same timer delay in decimal, then the initial value what we have taken is B8 3E, right? convert this B83E to decimal, that is 47166 you will get. 47166 you will get. The maximum value is here in decimal. If you are taking, it is 65,536 minus 47166, which is equal to 18370. So 18370 into t, nothing but 1.085 microsecond, again which will get us 19.93 milli. 19.93 milli. So this is how you can calculate the time delay with respect to decimal. So in decimal, first you take the initial value, convert that initial value to decimal, subtract it from the maximum value, that is 65,536, get the value, multiply it with by period, and the answer what you get, it is your delay. So till now what we have made the discussion, like setting the timer or stopping the timer. So we are mainly concentrating on the two bits. One is run control bit and the other one is overflow flag bit. So based on the timer what we are using, we are using the bits. For example, if you are using timer 0, then we use them as TR0 and TF0, right? So this is the bit which is existing in your TCON register. So hope you remember. So TCON is a 8-bit register. So where the lower 4 bits are for interrupt and the higher 4 bits what we have, that is for your run control bit and overflow flag bit, but for both timer 0 and timer 1. So this bit what we have, TCON 0.7. So you can see here. So TCON 0.7 is dedicated for timer 1 of overflow flag. TCON 0.6 is dedicated for run control bit of timer 1. Similarly 0.5 and 0.4 will be using. So now with respect to 8051 family, so this 8051 microcontroller what we are using with the 8-bit architecture, so these bits are these registers what we are using, TF and TR for timer 1 and timer 0, they were easily supported, so that we can use this registers name directly in the program. So there are some family which will not allow these registers to be written in. Instead they ask this TCON to be used. For example, if you go with the family of the controller like 89C51, so here instead of using TR and TF, they will be using, if you are using TF1, that will be taken as, consider as TCON 0.7. If you want to use TR1, it will be taken as TCON 0.6. Similarly for TF0 and TR0, that is TCON 0.5 and TCON 0.4. So now let's have a discussion by taking an example. So when we go with the family of the microcontroller, just now I said like 89C51. So here again we need to find out the timer frequency. For with respect to 8051, we said that the crystal frequency is nothing but 11.059 mega, right? So now if you want to find out this timer frequency, so we already always said that 1/12 of crystal frequency. So crystal frequency with respect to 8051 we took it as 11.0592, which will be keep on changing. It is not like mandatory that you will be always going with 11.095 mega only. So based on the family it will be keep on changing. So we have to keep in mind that the timer frequency is always calculated as 1/12 of crystal frequency. 1/12 of crystal frequency. If you go with this family 89C51, the crystal frequency of this is 22 megahertz. So if you want to calculate the timer frequency, then it will be like 1/12 of 22 megahertz. 1/12 of 22 megahertz. So we have to always keep in mind that the timer frequency is calculated as 1/12 of crystal frequency. Now we will take the program and we will discuss how this TR0 and TF0 what we have used, it has been replaced with TCON bits. So here you can see here, so we have taken the mode and timer what we have used, and next we are loading the initial value. So here you can see that the higher bit what we have taken is FF and the lower bit we have taken is 0 0. So here we have taken the port P1 and setting the timer. So setting the timer is always done by using this bit TR, that is run control bit. So all these examples we have discussed. In this particular example you can see here, instead of using TR we have used TCON 0.6. So just now I said how you will be using with respect to TCON 7, tcon 6, 5 and 4, right? So TF1, TR1, TF0 and TR0. So based on the bit you will be using. So here you can see that we will be using this instruction to check out the condition of your overflow flag, which will be generally written as TF with the mode what we are using with again, right? So instead of using the TF, we have used tcon point 7. Similarly, clearing the registers, both TR and TF what we have used, we have to clear it so that we can go with the second round of counting. So instead of using the register names, we have used it as tcon point 6 and tcon point 7. So tcon point 7 is nothing but TF1. So tcon point 7 is nothing but TF1. Tcon point 6 is nothing but TR1. So instead of using this register's name directly, we have used the tcon point 7, tcon point 6, which will be getting us the same registers like TF1, TR1 or TF0 and TR0. So for this, what we have taken 22 megahertz of crystal frequency, then you can calculate the timer frequency, which is equal to 1 by 12th of 22 megahertz, right? So 1 by 12th of 22 megahertz is nothing but 1.833 megahertz we will get. So with respect to this, you can calculate the period, which is t is equal to this whatever you have the frequency, which will get you 0.546 microseconds. So like this you can calculate in the same way the delay. So what we have calculated in the previous example, you can even calculate the delay.